Transmit beamforming is an optional part of the 802.11n specification that allows an access point to concentrate energy in the direction of a particular client using signal processing techniques at baseband. It requires feedback from the client to allow the AP to synchronize the transmissions from multiple chains such that those transmissions end up in phase when they are received at the client device and thus provide some additional link budget gain. Ruckus's beamflex technology, we refer to it as adaptive antennas, I think is probably the most accurate way of characterizing it. Beamforming is a baseband technique where you're actually playing with the phases of the transmissions at sort of the nanosecond level. With our beamflex technology, we are shaping antenna patterns physically by changing the antenna structure electronically on slightly larger timescales, typically microseconds or even millisecond type timescales. They really provide completely different types of gains, and in fact the gains are cumulative. Transmit beamforming in baseband can provide you a power gain equal to 3 or 4 dB depending on the number of transmit chains that you have. But there's no such limit for the adaptive antenna technology that we use with our beamflex. It's really limited only by the size of the antenna structure and the cleverness of the antenna design. The key with adaptive antennas, the beamflex technology, is that you can get gain from actually three different ways. One is just by focusing the energy in a particular direction, the straight up antenna gain that people are familiar with. You're just putting more power in the direction of the client you're interested in communicating with. That's similar to the gain that you get from transmit beamforming, but like I mentioned, it's not really limited by any sort of theoretical bound, only the size of the antenna. The other two sources of gain with adaptive antenna technology is the ability to control multipath, to be actually able to steer one spatial stream in one direction and a separate spatial stream in a completely different direction such that they end up maximally decorrelated and thus maximize the probability of doing spatial multiplexing. The third gain that we get from adaptive antenna technology is interference mitigation. Simply the fact that we're not listening 360 degrees, we're focusing energy in a particular direction so we're not creating as much interference. We're just simply better neighbors from an interference creation standpoint and from being more deaf to noise that's in directions that we don't care about. I guess probably one final thing to mention on transmit beamforming versus adaptive antenna technology is that as they're commonly deployed today, transmit beamforming is generally an alternative to spatial multiplexing. It's a way of using multiple radio chains, for example 2 transmit chains, to send a single spatial stream. So you get some link budget advantage from that, but you're not doubling the data rate like you get with spatial multiplexing. In many cases, it's actually better to be able to do spatial multiplexing if the client supports it, as opposed to doing transmit beamforming. So our adaptive antenna technology actually will work with both, and in many cases we prefer to do spatial multiplexing because it ends up having a higher aggregate throughput. Transmit beamforming and adaptive antennas absolutely can work together. In fact, one of the key things with adaptive antennas is it will layer nicely on top of whatever different PHY modes that you're using. For example, with 802.11n, one of the innovations we made with our beamflex technology was to use polarization diversity. This polarization diversity maximizes the probability that you're able to receive the 2 parallel spatial streams at the receiver and decorrelate them and constitute them into their individual streams. That was a pretty fundamental advance, but it turns out when you look at the other demands of transmit beamforming, it forces you to make slightly different optimizations. With transmit beamforming, you actually want the signals to be launched on the same polarization so that they start out maximally decorrelated. Typically, you'll have a single stream client that favors vertical or horizontal, and since you're only sending one spatial stream, you want to have that agility to launch both of those on the same polarization. So now we have this new antenna structure that, depending on the client, if the client is supporting spatial multiplexing, we can launch the signals with orthogonal polarizations. If the client is preferring transmit beamforming or is only a single chain device, we can then launch the signals on the same polarization as dictated by the environment.